Okay. How about now? Can people hear me? Yeah, audio is on. Yeah, now, Sean, you want to go ahead?
Okay. Well, I'll give this another go. So where was I? So those are some ways to do simple means tests. Yeah, so every analysis gives you a taste object where you can taste the syntax. To use the syntax.
Okay. I think another problem is your audio is still picking up from my machine.
Yeah, this goes.
So either I come close to you.
Let's try there.
Okay. Alrighty. You are a host. Give a second.
Okay, so here's the syntax that automatically comes up when you click the paste button. And it's fairly simple. You just highlight what you want. Basically, you could have 20 or 30 different analyses in one window here, and just run whatever you like. And then it'll run the analysis. And so this was that in gallery under publications. And now the other thing to note is that if we go to the notes on the output, this opens and closes if you double click it, is that this also gives you the syntax in this notes window. The other thing this notes window gives you at the top here is the data file that was used for the analysis. And so that's important so that you know what version you're working off of.
Would you like me to re-log in your machine? Will that help?
I don't know.
Just a second, people.
We're going to try re-logging in and see if that helps. Yeah, it's recording.
Sometimes it remembers and it wouldn't let me.
Yeah. Close Firefox thing. Just logging in again.
Breaks. Okay.
is the link for the Adobe account?
SPSS session.
This is not in the, I can see in the Word site. The art.
Place that here. If you have an echo. So 1 more minute, people. We are still trying to come.
Uh-oh. The default option is the Pearson correlation for normal distributed data. If you want to do, if you have some ordinal beta or other data, you want to treat it as the data is not particularly normal distributed data. There's other options here. The default option is two-tailed, and also to flag significant correlations. The options, you can also look at means and standard deviations, so that's handy. And this one down here is how does it treat missing values. So the default option is to exclude cases pairwise. So in other words, for each correlation between a pair of variables, if there's one of them, then it will be excluded. Listwise means that if there's a data missing for one variable, it's going to exclude that case for all the variables. And we'll see how that works when I do the multiple regression. It would exclude cases pairwise, but I don't think we have a missing data here anyway. So just look at the output. Now I like to arrange it. Pivoting traits. Start off the statistics variables by dragging one on top of the other. And you can see what that did is it puts all correlation coefficients in a little table that will paste nicely into a Word document. Then I've got the significance values below. And then it also shows the end. So if you did have missing data, you might have different ends for each correlation. The other thing that you can do, remember I mentioned, oh yeah, to pick them up right there. So the first one was actually the Pearson correlations, and I just switched the table for the Spearman's row. So I'll just double click this, and if the pivoting tray box doesn't come up, you can just right click, and you can see down here there's the pivoting trays. So you can see this again, I just swapped the variables and statistics because I like that view better. paste it into Word. Out of some options you can select variable. So let's say I wanted to look only at females. Well, I could just include those by throwing in this.
should be able to hear me now.
Alright, we're celebrating all over the internet. So hey folks. Hopefully, so far, by following the mouse clicks. Now where was I?
To diagnose some.
Oh yes, we're looking at some of the output options from the linear regression analysis. So again, you get descriptive statistics, correlations, you get the model summary for each of your steps, you get the ANOVA table here as well. Here we have a table with the coefficients. And so you get the coefficients for each step. And so you can see here you've got unstandardized coefficients, and those would be helpful, for instance, with this salary data. And you've also got your standardized beta coefficients, your t values for the coefficients, the significance values. I recall we selected the confidence interval option, and we also selected the various kinds of correlations, the zero order, partial, and part. At the end here you've got your collinearity statistics, which would be meaningful when you have a few independent variables in the equation. I'm just scrolling down. Oops. And here's those residual statistics and those plots, so you can diagnose. These will help you diagnose to what extent your data is linear or non-linear. In regression, you're interested in the residuals, and as you can see, they're not too bad, more or less normally distributed, and you can look at other, not just the histograms and PP plots, but there are other ways to examine this further that we talked about in a different workshop. No, just reviewing what I said I was going to talk about here. And so in this example, we actually did a univariate linear regression first, and then turned it into a multiple regression using those steps. If you want, we can look at the paste function just to see what that syntax looks like. And again, the syntax is contained within the outputs as well. Now, where did it go? So here's the regression. So you can see we have our old analysis there and this one here. So you can save all your syntax for this whatever particular analysis you're doing. And so with the outputs and the syntax, you have a good record of what you've done when you look at your thesis 6 months later or 2 years later, and you forget.
It's a request for people who lost audio to see if you can do a couple of minutes of intro of what you covered, so just what you covered.
Okay. So for those of you who've lost audio, I'll just briefly talk about what I covered so far. Basically, I hovered my mouse over top of the spreadsheet here. So this is the SPSS interface, and you've got a data view. At the bottom left here, you've got your variable view. And in a previous workshop, we talked about how to set up this data file. But in the variable view, you can change the way your variables look and the way they operate. So you can change the labels so that these names actually make sense. So time is kind of vague, so maybe it's time as a faculty member. Publications is number of publications. And we can also change the values. So for example, our female variable just says 1 and 0. The 1 means yes, the person's a female, so we can either put that in our values, label 1 equals yes, or we just put 1 equals, 1 equals female, and 0 equals male.
And again, if you watch the previous workshop, I go through this in a bit of detail. And this just makes it a little bit easier to read your outputs, because it won't show a 1 and a 0, which can be confusing because you might forget. It'll actually show male and female, and I can show that here by just looking at the means test we did previously. So you notice that it has all the variables where we left them. So that's handy. And now we have those variable labels changed. So now it says number of publications instead of just pubs. And I didn't select any options, I guess, so let me just run this one more time. We'll get the descriptive statistics. Oh, I forgot to show you some of the neat options in the one-way ANOVA. You can do a whole variety of post hoc tests, but we only have 2 levels of our independent variables, so those aren't particularly useful here. So you can see under descriptives, in this complicated table, we see that we now have, instead of 0s and 1s, we now have male, female. So customizing the variable view can be helpful, especially when you revisit your data 6 months later and you forget what all these things are. So I'd highly recommend customizing these variables. And so the other thing I talked about is just the menus are just like any other spreadsheet, and Analyze contains most of what you need to do. Although there's lots of data handling options that we talked a little bit about last time. So I think that brings us up to speed. And then I showed some of the means comparisons options and some correlation options where you can customize the outputs in terms of whether it reports at 1 or 2 tel. I just do 2 tel, and if I need a 1 tel, I just do the math from the output table. So are there any questions so far? Because I'm going to open a different data file if there are none. And we, despite the technical hiccups, we seem to be okay for time. So the next file I need to open is, well, you can just follow my pointing and clicking on screen. So this one's called Chapter 2 Multivariate ML1. And this is from Heck's textbook on multi-level analysis. And the reason I want this file is because we've got repeated measures here. We also have a covariate in socioeconomic status, and we have some factors such as gender here and number of courses. Now what I want to do is show you how to do some more complicated, more powerful ANOVA tests using the general linear model. And so under the general linear model, you can do your ANOVAs, your MANOVAs, your ANCOVAs, and so on. You can do it in a univariate fashion, where you would have one dependent variable. You put your dependent variable here, which might be your test score. You can put your fixed factors here, which could be gender, for example, and then a covariate down here, which is SES, socioeconomic status. Now we only have the one factor, but if we had more factors, well, the default is a full factorial model, but you can actually customize it. So if you have a number of factors, you could look at just main effects, all the two-way, three-way interactions, and so on. If you had multiple levels to some of the factors, you could do some of the interesting things. The plots are always helpful, And so you can have separate plots for, now this is just a univariate case, so it's not actually that interesting, so I won't do this until the repeated measures. This, again, you can save residuals into your data file, so you can diagnose to what extent certain violations or certain assumptions are violated. And then you have options for displaying means. With a covariate in there, you can actually get your estimated means based on the adjustment for the covariate. I always like to look at the estimates of effect size and parameter estimates, so when I go and do multi-level modeling, I can compare parameter estimates. Again, you can select these to diagnose violations or to what extent assumptions are violated. So I'll just go hit OK so you can see an example of the output. So the first thing it prints out is it just reminds you of your factor, the variable, and what the variable values are. Remember, this is a different data set, so I haven't updated what 1 and 0 means. And you get your descriptive statistics as well as the N. You get a test of equality of error variances. You get your between subjects effects. Parameter estimates, and then it will calculate, in this case, the mean values for the different levels of our between subjects variable based on our covariate. And then you get your univariate tests and then some of those plots we requested. Now we can do the same thing in multivariate. So here we can do a MANOVA. So let's say there are a number of dependent variables that should really be studied together. Now we don't have those here because all I've got are repeated measures. But if you had, say, a math and a science test, you could put both of those in here at the same time. So it might be appropriate to do a MANOVA instead of two separate ANOVAs. What I want to talk about next is repeated measures using the general linear model function. So what we have here is a repeated measures MANOVA. And so the first box gets you to set up the levels of those repeated measures. And so I usually just call it time for because that's what I've always done, but you can call it whatever you like. In this particular data file, we've got 3 tests. So if you recall from the data, there was test 1, test 2, and test 3. And you can actually do multiple measures. So let's say you had time 1, time 2, and time 3 for math scores, science scores, English scores. You could label all of those here under one variable. I've only got, I don't know what it is, so we'll just call it English. But you can have, and it labels it English. But you could have, if you set up that previous screen, you could have all the way down here all of those different test variables. And so all we do is highlight these by holding down the shift key, or put them in one at a time if you like, and then arrow over, and we've got our 3 repeated measures. And so we'll just look at that first. I'm just adding a few options so we can just have a little look at the means and so on. And the plots are always good to look at. So I move the time over the horizontal axis, and you'll see what that shows us. So again, we get our variable names, our descriptive statistics, and then we get some multivariate tests. You get this test of sphericity, and in this case it's violated, so you might look at adjusting the degrees of freedom, and so you have options for that already presented. So here we see the within subjects effects with adjusted degrees of freedom depending on how important the sphericity violation is to you. Or if the reviewer of your manuscript says you should report this instead. we have no between subjects variables, but then we can see the plot, and so it gives you a nice little plot of how these test scores changed over time. Now you might want to adjust the y-axis there. So that's your basic repeated measure. You can look at it's significant here, that change in time, and you've got your effect size here, which is pretty big. The next thing you might want to do is look at some between subjects factors. So this will just leave like it is. You might want to look at some between subjects factors, like how many courses they've taken, or differences between men and women. So we're going with the full factorial model here. We're not going to customize it. We'll change the plot a little bit so that we can have a separate plot for men and women. So I'll add that. Oops, didn't want to click that button. Separate plot for men and women over time. Sorry, separate line for men and women over time. And we can also look at the means, and if you want to look at some customized outputs, they're all here. So now we've got the multivariate tests, including this interaction between time and between subjects factor of gender. And again, in the within subjects effect, we've got time and the interaction here. Then we also have a simple between subjects effect. So this is just an ANOVA between men and women. And that option we selected for output gives us mean times the means for each group, as well as the interaction. So we've got time 1, time 2, and time 3 for men, and time 2, 1, 2, and 3 for men and women. And then we've got the same graph, and then this other graph. So not much difference there. And then the last thing I'll show you with the general linear model of repeated measures is you could add the covariate here of socioeconomic status. Let's make sure everything is the way we want it. And so now we actually get to look at an interaction between time and socioeconomic status. And I'll just skip way down to the bottom here to look at the adjusted. The adjusted means based on the covariate. So I realized that was a whirlwind tour of repeated measures in ANOVA. Are there any questions? So if that's something you think you might be using, I can go over that again a little bit more slowly. And at the Amos workshop, I'll be showing another example of how to look at repeated measures data. Now we should do this. Is there any questions on some of those multivariable type models, or something else you'd wanted to look at in those data files? Because I'm just going to briefly talk about a non-parametric test after this. Okay, let's give you a moment to type. That's my data file. So this next example is in the category of I have wonderful data for demonstrating non-parametric tests, but I can't share it with you, so I had to find some data from textbooks that's not quite as good as what I have. But here's a typical setup that you might see if you want to analyze some non-parametric data. And in this case, I'm comparing proportions. And so what we've got here is an ID number, so say patient ID. This is a treatment group. And then the next one is a presence or absence of disease. And so there are a number of ways to analyze this. And I'll show you, I think, just the quickest way. So
The
I'm just...
second column was exactly what?
This one?
Yeah.
Group is the treatment group. So let's say these...
What is 2, what is 3, and what is 4?
Well, they're really arbitrary. That's treatment 1, 2, and 3.
Okay.
And that could...
So different treatments.
yeah, different treatments. And this data I just made up,
Okay.
but it's inspired by some data from the example I'll use next.
Some numbers we could use in parallel information.
Yeah, so control group, treatment group, drug A, B, C. And so one way to do this is to go into the descriptive statistics menu, and it's I don't know why it's hidden here. Well, I do know why it's hidden here, but because there's lots of things you can do with it. But you can go to the crosstabs function and set up your table here. So let's put the group in row, and the column will be presence or absence of disease. Now, yeah, I don't think you're going to have the exact option in your free version, so I'll just leave that alone. But you can see in the crosstab statistics, you can do a lot of things depending on the nature of your data. So if you have ordinal data, there are some options. If you're comparing raters, or let's say you've got data from two pathophysiologists who are trying to diagnose cancer in some tissue, and you want to compare person 1 to 2, you've got your different ways of doing that. So anyway, there are lots of options here. So I'll just select some. You can set up your cells, so you can look at adjusted standardized residuals, what I like to look at. You can look at your percentages, and I'll do that by row, because what we're going to do is compare proportions of people who have disease and not disease based on their group in the experiment here. And so we look at row percentages. And you can even look at some charts depending on the nature of your data. And so skip down here. So in this particular example, we actually have labels for those numbers apparently. So we've got tissue types A, B, C, and critical. And you've got the presence or absence of disease. And so what we're interested in is, are there differences in the tissue types between the presence and absence of disease? And so
tissue types were the column, was the column 2?
Tissue types are put into, oh yeah, I'll go back to the spreadsheet here. Well, the first column is simply the ID number of the patient. So the first data column is the tissue type, yeah.
Yeah.
I didn't realize that was labeled. So I'll show you this button here. If you have labels, clicking this button switches between the number and the labels. And so you've got results of the tests, and none of these are significant. And This is a really small sample size, so that's a problem, but what you're interested in is, gee, it looks like type B have fewer presence of disease than the other types, but that's not apparent from this data. But the point of this exercise is to show you that typically you'd have your data represented in this. But there are instances where you might get data written on literally a piece of paper or in an email. And so I'm going to show you how to set up SPSS to do this a little more simply. And that's contained within this file here called Chapter 11 Tissue Type Large Sample. So this is the same format, but what we've done here is we take every possible group type combination with the presence or absence of disease. So you could be type A tissue, no disease, type A tissue with disease. And so that takes 2 lines to do that. Type B tissue, no disease, type B tissue with disease. And down the list. So these are all the possible 8 cells in the table. And then what we do is give a count number. So there's 14 people with type A and no disease, 8 people with type A and disease, and so on down the list, because this might be the only information you get, and this is the kind of stuff that physicians or their assistants will send me and say, analyze this data. And so what you do with this is you go to data and weight the cases. And so we weight cases by count. And so this will take, SPSS just logs what we did. So it'll record that you did that. And so, this is just another option for presenting the data instead of that big, if we had all this data, because I didn't have that many participants in the previous file, this is just a different way of handling that. And we can do the same analysis. Now keep in mind the data is a bit different, but we can do the same thing. So we've got presence in the column, group in the row. We can look at some of these things if you like. The cells, I always like to look at the adjusted standardized residuals, and I'll tell you why in a second. And then we hit OK, and we see the table is the same, but of course the numbers are different. And so this shows you how the presence or absence of disease varies by tissue type. You can jump ahead to your chi-square statistics and some of the other measures, and it shows that, okay, there's a difference between presence or absence of disease depending on tissue type. And so one way to look back at our table is you can look at the percents and say, okay, it looks like maybe type A's got a disparity between presence or absence of disease that's stronger than, say, type C. And what the adjusted residual does is it shows you a Z-score. And so that will give you an indication of, okay, this looks like it's a 2 standard deviation difference. This looks like a 3 standard deviation difference. So these two seem to be the source, or the largest source of the difference. Does that make sense? And so those are a couple of ways to look at your simple non-parametric comparing proportions. We'll just see if anybody has questions on the line. Sure.
Some moment we thought that maybe there are some difference between the free version and the paid version. So the software, the free version is different because some functions are not activated well. It's not based on length of time that we would.
Yeah, so there's a question about what's the free version, how does it differ from the full version? Well, the paid versions differ as well. So the basic SPSS program doesn't have some of the more advanced options, like, and I'll show you some of those. doesn't have the more advanced options like multiple imputations and missing value analysis. There's bootstrapping built into the advanced version of SPSS. And so a lot of those options will be missing. So let me just see. In fact, I don't seem to have it. I think there's supposed to be a bootstrapping option built in to some of these analyses that I don't see. So my version might not even have that. But you can buy more advanced versions and add-ons. Typically the free versions just limit you in the number of variables and the numbers of cases, which is another reason I use the textbook data files, because they tend to be very small, so that a free version will actually accommodate. Okay, I'm just waiting for questions. There's a couple of things I'll show you that people often ask me about. I'll see what some questions are. There's a question about SPSS graphs copied for use in publication. Yes, just like you'd use Excel to generate a graph. And last time I actually showed you how you can customize your outputs so that the graphs look more or less like some format. So I typically customize my outputs to be close to APA format. And so you'll notice my graphs are black and white. And so you can just copy these tables, right? So you can copy the table, you can export the table. And the graphs, you can actually go in here and customize them a little bit. So there are a number of customization options, and I think we went over this last time. So yeah, certainly you could do that. There's no questions. I'm going to open up another data file and just give a little bit of background on handling survey data, which will sort of set us up for the AMOS, where we use AMOS to handle survey and questionnaire data.
There are Pearson and Newman, so how many options? But there's some analysis model or sample.
Well, there's a question about when to use Pearson or Spearman or some other non-parametric. Well, the Pearson is based on parametric data, so you're assuming roughly normally distributed. But if your data is non-parametric, such as, say it's ordinal and there's only 5 categories, you might use a different correlation. For example, the Spearman, which is a rank order correlation. Or if your data is severely non-normal, so it's not a perfect bell shape, maybe it's really indescribable, you might use the rank order, which is what the Spearman does. And there are other ones as well. There's other options in there. So the answer is it depends. Or there's sometimes it's a gray area, and I submitted a paper and the reviewer said you should use this. I'm like, yeah, okay. It doesn't change it very much, and if that's what you want, sure. So I've just opened the Burn BDI data, and so this is data from Barbara Burns' book, which I have listed as a recommended textbook if you're interested in getting into AMOS more. And I'm just going to show you how we might handle this data a little bit in SPSS, and in particular calculating the liabilities of subscale scores. I'm just going to get Burns text so that the values I come up with make sense. Thanks. So the BDI is the Beck Depression Inventory, and I'm just going to show you an example of how to calculate liabilities for one of the subscales. And I just need to find what page does she have listed the subscales. So to calculate reliabilities, we go down to scale. And we simply pick the items we need for the particular scale. And I'm going to do the somatic element scale, which doesn't mean anything to you, but it's only got 4 items, so it should be easy. So we've got 4 items in there. We can select our descriptives for the item, the scale, and the scale is what you calculate from the 4 items. The scale if the item is deleted, the inter-item correlations if you wish, as well as a number of other options. And typically in a survey like this, you'd just be interested in the alpha, and that's Cronbach's alpha. And again, when you revisit your output 6 months later, it's always nice to know what you're looking at. So adding a scale label is helpful. And I'll click OK. And so again, you do have the syntax contained within the output in case you want to use that. So the first thing it gives us is the Cronbach's alpha, and then the alpha based on standardized items, and the number of items in our scale. It gives us the mean response on each item, right here. The inter-item correlation matrix, which may be useful in diagnosing items that are particularly poor. And one thing that's kind of useful to look at is the item total statistics. For example, how does the scale mean change if the item is deleted? How does Cronbach's alpha change if the item is deleted? So if we saw any really large Cronbach alphas here, we'd know that a particular item wasn't very good. We see if we remove item 15 over here, that Cronbach's alpha reduces sharply, so that's probably an important item. And this is just as an example. So I'll just do that one more time, just so you can see it again, and just so we can compare another subscale. So the next subscale is going to be performance difficulty. And here we've got item 4, what is it? 4, 11, 12, 13, 17, and 19. See, that's what we want. And so again, here's our scale, but this time for performance difficulty, our Cronbach's alpha is 0.8. Typically you'd want over 0.7. For something like this, maybe even higher if it's a diagnostic tool, which this is probably intended to be. Again, we've got our correlation matrix among the items. I'll skip ahead to the item total statistics. We can see deleting items doesn't change things a whole lot. So So they're all contributing roughly similarly, and that's what you see in the correlation table. And so that's how you would calculate your reliability statistics for all of your subscales. For those of you using surveys. Any questions on that? I'm just waiting, I see some people are typing.
Yes, Sean, I'm using a survey. So this is probably what I'm using them. Or are there other tools that I could be using? Or is this commonly used? Mine's about estimates and exercise. There's lots of
Well, if you're using any kind of measure, people are interested in the validity and reliability of the measure. And so if the measure happens to be a survey with multiple questions and subscales, as a reviewer, I'm always asking, what are the reliabilities?
Yeah.
And the reliability of the survey depends on the sample.
Right.
So it's really sample dependent.
Yeah.
So we need to know, okay, it was great when somebody used it in a sample in Quebec, but how is it in your data?
Okay.
Very handy.
Yeah, and we'll see that when we use Amos, we can actually get, Amos can adjust for reliability. Now, if you're doing something like linear regression, an assumption is that measures are perfect and perfectly reliable, but that, of course, is not meant ever in practice. But Amos actually adjusts for reliability. And you can actually adjust your correlations by hand if you know your reliabilities, but that's a bit slightly tedious. So the effect of poor reliability is your correlation among variables is smaller than it should be. And Amos adjusts that, which is one of the neat things about it. The question, I don't know. That would be kind of nice, but they do have an extensive help file. And on some of these outputs, you can actually right-click and get some information.
We'll be reading at 12:30 with the example book. So when we read, make sure everything is up.
Now, there was some SPSS. I recall having a results coach option in SPSS, and I don't know where that is right now. But it kind of walked you through some of the outputs. But each analysis has a help button. And that will tell you about everything on this page. And even the sub-menus have help buttons. So if you click help, it'll give you a little bit of background on some of these things. So I just clicked help here and you'll see it's very slow, that's the only thing. So again, with every analysis, there's always a help button. So it's good to look at. Now you can see it takes a long time to open sometimes. That might just be my computer, I don't know. So I'm just going to close that because anybody can pursue that whenever you like. So does anybody have any questions or requests?
My only concern here is about the price. I'm just seeing here $4,000.
Well, you can, AU has a link to a software store that we have a partnership with called On the Hub, where you can buy, I think, a 12-month license for roughly $100. And again, our Faculty of Grad Studies is working with the research office to try to obtain licenses for students in a sort of orderly way. And I have a meeting about that actually on Monday. Well, there you go. Madeline says statistics coach under help menu. See, I thought I saw that somewhere. Oh yes, statistics coach. There you go. So there are some good help options. And in your package, I sent you a link to some good online resources, some good text resources. And I actually bought a free book if we want to raffle it off somehow. It's got some. The publisher sent me a free version about a month after I paid for it, so I got two of these copies. So we can think of a fair way to raffle this off. It's got SPSS examples, so it's pretty good. I've got dozens of these, so. So I think we could take a break if nobody has any questions for how long, and then I can just go right into the Amos workshop. Well, maybe 10, so I can get a coffee. Is 10 all right?
10 minutes.
Okay, and if on the break you think of something that you wanted to see, some kind of analysis, or if you wanted me to redo something. I didn't talk about mediator and moderator models because I thought that would be too complicated without like a chalkboard basically to draw on. Okay, thanks folks. Oh wait, we'll wait for Josie to finish type. Oh, she's done. Should I guess stop this then, right? Stop recording? Or let it record dead air? Sure.